Hi everyone. We're working in Algolia and we're here to discuss with you the challenges we face while trying to have learning to rank in production. So I'm Sarah, I'm from Paris, and I'm working on machine learning topics.
Hi, I'm Claire. I'm Claire. I'm machine learning as well at Algolia. I'm from Paris as well. And a fun fact about me is that at the end of high school, my mom really wanted me to get into EPFL, and I didn't have good grades enough to get in. But I'm now here today, so really happy about this. So Algolia, we are a search as a service such as a separate company. We provide a search engine, but not like a Google. Sorry, but not like Google. Rather, for anyone to use and set up to search their own data or their own catalog. It means, for instance, if you go on the Times, the newspaper, you type in a query, it compares to all the published articles, and it's going to select the most relevant and present it to you. And that's where Algolia steps in. It's a search for others. So the goal is not to sell you Algolia, but those numbers are going to be key throughout the presentation, so let's go quickly through them. We have over 70K customers with a service level agreement of 5 nines, which is under 6 minutes of downtime per year. One search request is between 5 to 10 milliseconds, which is basically results coming up as you type. And finally, it's a service platform, so it's not only provides search as a service, but also package AI feature from data setup to model setups, which are completely abstracted from the user. So let's dive in the topic. What's learning to rank? What do we expect from it?
So first, what's learning to rank? According to Wikipedia, learning to rank is the application of machine learning in the construction of ranking models for information retrieval systems. So in short, it's the use of machine learning to solve ranking problems. By using it, we aim at improving the ranking by placing the most popular documents on top of the search results, and by doing that, improve our customers' metrics, such as the conversion rate, the click-through rate, or even the views, depending on the customer's use case. At Algolia, we are serving very different customers with different needs and catalogs. So for example, we have e-commerce, marketplace, or media. And so we have to handle very different documents. Here you have 2 examples of documents we would have to re-rank. And so as you can see, they have nothing in common. They don't have the same size, they don't have the same attributes, they don't have the same types. Or the same structure. And so we do have to work on what's the relevant data and all that for ranking. We are also offering different features which can affect the ranking. And so we have to handle some possible conflicts between those features. So since learning to rank is a way to optimally combine different signals, we can see those different features as input signals for learning to rank. And so this would be a way to build an optimal final ranking. So that's the plan, but now let's see how it goes in reality.
So we're going to see the model, the data, and the target to actually have some learning to rank at Algolia. So start, what do we need from a model? Customers tend to update their data quite frequently. For instance, product going out of stock, and we need the end model to reflect this. So we need to at least a daily retraining of the model. So we need something which is quick to train. Then, remember, 5 nines ASLA search is between 5 to 10 milliseconds. If we want to be on the search path, we either have to match those requirements, either we don't put ourselves there. So here, we choose to do offline prediction, and then we need to do as much prediction we can for one customer to make sure we cover as much traffic as possible. So we decided to go up to 300K prediction per customer. So we need something which is a model which is going to do prediction quickly. Then, we want to avoid any extra operation because we don't like to work. So we want to avoid setting up a TPU. As well, we want to avoid the extra cost of GPU, so focus on CPU-friendly models. Last, we need to understand the end ranking, but most of all, customers want to understand. They need the agency and they need the visibility. So we need something which is explainable. And this rules out language model and large language model for us. We would rather work with more common, more naive solution like decision trees and boosting. We have our model. What's the ranking we are aiming to match? Customers rarely go telling us, I would like this result to be other for this result for this reason, or I wouldn't want to see this result for this query because it's irrelevant. So we have to use, and even if we would spend some time annotating the data with the help of language model, it wouldn't scale to all the customers we need to cover. So we are going to use past view, clicks, interactions as a proxy to what customer want to see, view, why. And we're going to use it to build our ideal ranking. And the good news is, there's one good news, is that we already have a statistical re-ranker in production using these user engagements to re-rank the results. So we know that it's a good target because we know it has shown some improvements on customer business metrics like clicks and conversion rate. Now we have the model, we have the target. What's the inputs? At Algolia, but generally in ranking, we have 3 types of inputs. Document-based, which can be related to the content, the price, recency, or the popularity of an item across all queries, meaning it's frequently bought, whatever the query is. Then query-based features, length, occurrence, number of occurrence of the query. And finally, signals, which are linking both query and documents. So the number of typos you have between your title and your query, or the semantic score between your document and your query. The semantic score for us is the cosine similarity between your vectorized query and an average weighted representation of selected semantic weights within a record. But we have to do it 70K times. Thing is, one thing we might learn is not going to be true for all customers. For instance, as Sarah mentioned, one attribute might not be present for all the different customers we have. And one attribute might not be as important from one customer to another. Publication date, extremely important for news, not relevant at all for books. Lastly, customers are not going to have, even if they have the same attribute, like same price, it's not going to be formatted the same way. Currency signs, for instance, go at the beginning, at the end of the price sometimes. Most common example in computer science, dates, billion different formats. Just between the US and Europe, we do not read the same date the same way. So we are going to require a bit of configuration from our user to know what's going on. And the end conclusion of all of this is that we need to have one model training per customer because we have different data modeling at the beginning, different data distribution, means different weights to learn for each of them. One architecture, but different models. And on top of all the problems, we have the usual ranking problems. So we are going to face selection bias. We are only re-ranking what the retriever is giving us. So we might have an extremely relevant semantic signal. If the retriever didn't pick it up, we're not going to be able to re-rank it. We also have presentation bias. Because we are learning on historical data, the model is likely biased by the current ranker or re-ranker in production. So it will learn to mimic the current ranker. And lastly, some customers, for instance, would like to see a lot of personalized results being ranked higher. But query personalized tend to represent 2 to 3% of the total traffic. So it's not enough for the model to be able to learn it's an important feature and it's not taken into account.
So if anyone here is working in ranking, you know it is biased. The idea when you work with ranking is to bias the behavior of the end user. And so you will have to face this bias when working on the training or on the evaluation, for example. But still, there are things we can do to attempt to debias a little. So first, we could focus on pairwise models rather than on pointwise, because those models are not learning the raw scores. They are more learning the relative relevance of documents, one compared to another. And we could also think of introducing beta distribution in the building of our target. By introducing beta distribution, we would have the negative signal taken into consideration in addition to the positive one. So what we call the negative signals are the views without any interaction with the documents. And so we would also score the non-seen documents and with some kind of average score. And so all this would allow sometimes the unseen documents to be ranked higher than some very seen documents, but not so popular because not interacted with. We could also think of introducing weights on our events, based, for example, on the dates of the events or on the place of the document when it was interacted with. As we said earlier, we are facing the bias for the training, but also for the evaluation. And so today we do have a solid baseline, which is based on tie-breaking and on textual criteria. And we have, well, our baseline is very transparent and it's understandable for our customers. And so we have to prove that what we are building actually adds something, has more value, and improves the search experience.
Okay, in that case, maybe we can share the training metrics, precision, recall, F1 score, and DCG.
Well, we can do that, but I'm not sure how you relate your F1 score, for example, to the amount of sweatshirt a customer will sell, sorry.
Okay, that's a good point. But then we can reuse the historical data we have to replay the queries with the learning to rank re-ranker outputs, and then compare for given queries a change of performance.
Well, we can do that, but it won't be enough because we will face what we call position bias, which is kind of related to what you introduced with presentation bias. And so this won't be enough because an item placed, for example, on the 10th position has way less chance to be clicked or interacted with than the one placed on top of the search results. And so using the historical data would help to know if, for example, we are not burying a very popular item, but it's not enough to estimate the relevance of what we are placing on top of the results. And adding to that, we also have some legal and security constraints since the data we are using is not ours. We are not able, for example, to switch cluster. We have to use it on the original cluster, which is a production one. And we also cannot reuse the data across customers for the training or the evaluation, for example.
Okay, I fairly understand why we cannot go completely offline. But that maybe we can set up an A/B test. On one variant, we put the classic search as it is today. And on the other one, we set up learning to rank with the re-ranked results as output. And then we can compare for the same query, different user, the change of performance, and we can directly map this to customer metrics.
Well, yes, but this means that to test a new idea, we have to be production ready, and we have to be confident enough to know that this idea will actually impact our customer traffic. And so we cannot test everything with A/B tests. And the important thing in the end is that you have to know the different limitations of the different evaluation methods you have to be able to correctly analyze your results. And in our case, we will have to combine both of the evaluation systems. At first, we do offline evaluation to gain in confidence and to be able then to start some A/B tests with online evaluation. So as we said before, in Algolia, we have a commitment to be stable and to be reliable, and we do have to keep that in mind when we are iterating. And so our re-ranker has to match our SLA and to be able to support the load. We also have to keep up with Algolia speed, search speed. And so, for example, the statistical re-ranker we have today is out of the search pipeline, and the ranking is computed offline, which helps to limit the negative impact it could have on the search. And we have to keep that in mind and to find a way to mitigate the negative impact we could have. Another way to do that is that we could also, we have the top queries. We have the top queries, which are the most important queries for our customers because these are the ones that have the most traffic and are bringing the more revenue. And so we could decide to leave what we have now as a re-ranker for the top queries and to only try our new re-ranker on the tail queries. So it's way less risky. But the issue with that is that, since those queries have way less traffic, we would have way less insight. And so another thing we could do, we could combine both, would be to save only one spot in the top queries to try what we would re-rank with a new re-ranker. So it's not that risky because it's only one item, but still we would have a lot of insights on this. So yeah.
So we've seen how production and Algolia's being a search as a service company affects the decisions, design, and the choices we make to introduce learning to rank in a search pipeline. If we get back to our first definition we've seen of learning to rank, that it was basically machine learning models applied for re-ranking. That's what I read. What some people might read is that state-of-the-art models solving all the ranking problems, figuring out perfect ranking on their own, saving us and customer a ton of manual work, and it even makes coffee.
Well, not quite. Here would be a more accurate definition of what we are trying to build. And so, as we said today, working in production implies a lot of constraints. And so we are actually not able to implement state-of-the-art model, and we don't optimize locally or target perfectly the need of each customer. What we are trying to do is to find a solution which is good enough for all of our customers and which is, well, generic enough to abstract the information relevant for all of them. So thank you for listening to us today. Feel free to ask questions, maybe now if you have time, or even later. We'll be in the break room or we'll be around.
Is there any question? In this case,
very simple question. What are your models? What are your models?
So we are evaluating today CatBoost. Oh, just the microphone, I'm done. Today we are evaluating CatBoost with different plot functions.
So no neural nets.
No, not explainable enough. Not easily explainable enough.
okay, thank you very much. I'd like to invite the speakers to take their place on the round table. You don't have a microphone. Yes, test. So there will be two phases. I'll start with a generic enough question for you to comment on it, and then we'll open this to everybody. So we've seen revisiting history, revisiting past research directions brings a lot of improvements to dense models like neural nets. We also seen exciting new applications like conversational approaches to search via question answering. And we also saw that simple is efficient, essentially. What we know that worked well for several years, put in production, there are a ton of advantages about it. I'd like to get your feeling like in a domain that is moving very fast with exciting news and new benchmarks and new state-of-the-art models every day. What makes you most excited today? Anybody who would like to start answering?
I'm not excited, I'm skeptical. Because I think the evaluation is a bit broken. I think, as you've shown, that most public data sets are far from the true reality of search problems. And so I'm more concerned about really the claim and evaluation of those things. I'm really excited by those LLMs and what they could do, but right now the efficiency part is not there yet. So this is, to me, one of the most interesting things, because when we saw BERT like 5 years ago, then people started to change architecture, change a lot of things, and then optimize things differently. And then we have new things that appear. So maybe that's the thing that I expect or excite me, is that with even bigger LLM, new things will come. But to do so, I think we should have better evaluation and better data sets. And they are a bit missing to me. So.
It feels that evaluation was in all three presentations, so good point. Yeah.
So yeah, I'm not sure if it's like exciting. On one hand, it's exciting. On the other hand, for me, it was a little bit not so exciting. This what I mentioned at the end of the presentation about the arrival of the long context LLMs, and because that made me thinking, okay, do we still need RAG if you can like feed the entire books to the LLM and potentially even entire databases and have it reason? But the answer to this is we're still not there. One is efficiency that also Stefan mentioned, because like it's not efficient at all to like use a generator, like process all this information at one step. Even like for much shorter contexts, it takes time to get responses, and I think it will be a game changer in a sense if we are able to have these results quality with a system that is much more much lower latency. And the other reason why this long context approach is not there yet is actually performance. So there are these benchmarks of like needle in the haystack, where people are showing very good performance, like close to 100%. But if you do something more realistic, like some people tried multiple needles in the haystack, and you see that performance deteriorates as you have to retrieve more facts from the context, and also as the context size increases. So at least in the case of RAG, I think it's still important, at least for the like next year, if I can predict. I cannot predict further than that.
Yeah, I see. Yeah. I mean, context is also money, right? If you send the whole book every time you try to answer a customer's query, you will pay probably a lot.
Yeah, even if it's an in-house model, still like having such a model, like a very huge model deployed in production, is costly. So yeah, that's another factor.
So what excites you?
It's a bit in the same idea of what Stefan said, is that, well, even if we presented that today we're not able to use state-of-the-art and we are using some less trendy things, I guess what's now trendy and state-of-the-art will become the normal. I think we are evolving. It's still exciting to see what's coming, even though it's maybe coming a bit more slowly than what we see in state-of-the-art. And so we are, I guess I'm still quite excited by everything new we see, and we will be able to use at scale later, I guess.
I think one thing which really naively I find really exciting is the end understanding coming with language models. I know it's not right there to scale and production, but I still have the magic thing of, okay, gets it. It has lots of limitation and everything, but I found it impressive. I'm still impressed.